Hey everyone, it's Mr. Egbert. I am going to make some videos this week to go through the examples that are on the worksheets that you have to do. What I'm going to suggest is that the videos are optional, and if you can figure out how to do what we're going to do this week by looking at the examples on the worksheet, feel free to do that. If you feel like you're not understanding what's going on, watch the videos, because I'm just going to talk through the examples that are on the worksheets, and that might help some of you a bit. So the first one I'm going to make is about simplifying radicals. So simplifying radicals, if you've looked through anything so far, you'll know that radicals, or radical, is just a fancy word for root. So we're going to be talking about square roots this week. There are many different types of roots, but we're just going to focus on square roots to keep it kind of simple, since we're doing distance learning. The first example that's in the worksheet is the square root of 24. And what we want to do is we want to simplify that. And when I say simplify that, is what I mean is we want to try and take any perfect squares that are factors of 24 and remove them from the radical. Okay, so basically what I want to do is I want to start by making a list. Let me see here. Let me make a list over here of perfect squares. So I'm just going to draw a little square here. So when I say perfect squares, what I mean is 2 times 2 is 4. So I'm going to write 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. And I'm going to stop there, even though there are plenty more perfect squares, but I'm going to stop there because the number that I need to simplify is 24, so there's really no need for me to go beyond 24. Really, there's no need for me to go beyond half of 24, but you know, it's okay to list a few extra ones. The thing I'm going to point out right away is that, hey, I can get rid of 25 because it's bigger than 24. I can get rid of 16 because I know that 16 doesn't go into 24 evenly. I can get rid of 9 because it doesn't go into 24 evenly. So that leaves me with 4. And I know that 4 goes into 24 evenly because 24 is equal to 4 times 6. So what I'm going to do is I'm going to rewrite this as the square root of 4 times 6. Now this is slightly different than what I did in the worksheet because I immediately split them into 2 square roots, but I'll split it into 2 right now. So we have the square root of 4 times the square root of 6. And then what I can do from there is I know that the square root of 4 is 2, so I can simplify that. So when I say simplifying radicals, what I mean is we're going to take perfect squares like that and simplify them. So we can say now that instead of the square root of 4, we can write it as 2 times the square root of 6. So the square root of 24 simplified is 2 times the square root of 6. Okay, let's do another one. Let's see here. We'll go to another page. Let's take one like, well, the next one in the worksheet, square root of 72. Okay, so first things first, I'm just going to make a list of those perfect squares over here. So I'm going to draw a little square to remind me that they're perfect squares. So what I'm going to do in this case is it's 72, so I'm only going to go up to about half of 72, which would be 36. So I'm going to go 4, 9, 16, 25, and then 36. Okay, next one would be 49, but hey, that 49 doesn't go into 72 evenly, so we can get rid of it. 36 does, so I know that's going to work. 25, does 25 go into 72? Nope, because it ends in a 5. 72 would have to end in a 0 or a 5 for 25 to even have a chance. Let's see here, 16, does 16 go into 72? Well, now, you know, you might look at some of these and say, oh, I can't tell if 16 goes into 72. Well, just grab a calculator and do 72 divided by 16. If you get an integer, then it goes in to 72 evenly. But in this case, 16 does not. But then 9 and 4 both go into 36, so that means they go into 72 as well. So we have 3 different numbers from our perfect squares that work in this case. Now, the key thing is when we're simplifying, we always want to do the most that we can do. So in order to do the most that we can do, we want to always take the largest perfect square and remove it and simplify it. So in this case, the largest one is, it's kind of hard to see that green highlight there, but it's 36. Okay, so I can say, okay, so I'm going to take 36 and try and write it as 72 as a product of something times 36. Well, I know that 36 goes into 72 2 times, so I can write it as, let's see here, I can write it as the square root of 36 times the square root of 2. And then I can simplify the square root of 36 because I know it's 6 times 6, so I can write it as 6 times the square root of 2. So the square root of 72 simplified is 6 times the square root of 2. Okay, let's look at another one. The next example in the worksheet is the square root of 343. Now this is a good example of one where when you make your list of perfect squares, you're going to have some big numbers that you're dealing with, and a calculator is going to be really handy because it's not always easy to determine whether or not something divides something evenly, especially something like 343. So we have perfect squares. We have 4, 9, 16, 25, 36, 49, 64, 81, 100. Ooh, we're running out of space, but we need to keep going. So I'm going to move over to the side a little bit. So 100, 121, 144, 169. I think I can stop there because the next one is 196, and that's greater than half of 343. Now, if you are struggling to make this list of perfect squares, just remember that 4 is 2 times 2, 9 is 3 times 3, 16 is 4 times 4. So just grab a calculator, multiply those two numbers together, and just keep going in order, and you'll make your full list. Okay, so what we need to do is figure out 343. 343, how are we going to do this? One thing that we could notice is that 343 is an odd number, and there's no way I can multiply an even number by anything that would get me an odd number. So that means I can eliminate all my even numbers. So I'm going to eliminate all of those. Okay, and then I can just start to look. 169. Well, 169 times 2 is 338, so that one doesn't work. 121 times 3 is 363. It's close. It's not 343. It's 363. So I can get rid of that one. 81. So if we do 343, here, I got a calculator. 343 divided by 81. Here, let's see here. 343 divided by 81. Oh, that's a decimal, so we can get rid of that one. 343 divided by 49. Well, there we go. That's 7. So 49 is going to work. And since there are no numbers bigger than 49 left on the list, we're good. We know that we can use 49. So I can rewrite 343 as the square root of 49. And when I did the division on the calculator, I realized it was times 7. So it's going to be times the square root of 7. So we end up with simplifying square root of 49 to be 7, so we have 7 times the square root of 7. Okay, I hope this helps. If you need any other help, feel free to email me, put something on the discussion board, or try and make it to office hours this week.